So first we need to look at particle theory. So this is a central concept in chemistry, and it's really important to understand what particle theory is. So it states that all matter, everything that we see around us, is composed of tiny particles that are constantly moving, okay? Now the motion is determined by the particle's energy. So if a particle has a lot of energy, it will move, similar to a kid. If a kid has lots of energy, they'll be running around. And its relationship to other particles. So for instance, a particle moving in this direction, if it collides with another particle, then obviously they're interacting and its direction will change. Just like a billiard ball here that we can see here. If two billiard balls hit each other, then their direction will change and that changes their motion, okay? And that's what it means. Now this particle theory can be used to describe any state of matter that we see. So now that we've got particle theory, or the basics of particle theory, we can subdivide matter into three categories. And the first is elements. So as you can see here, an element only seems to have one type of particle in it. See, there's just the brown particles here, or the green particles here. They're just one unit, one type of particle. You can have compounds. So as you can see here, you've got, a blue and a yellow particle combined together, and that sort of repeats itself. Or here you've got two white particles and a pink particle combining together. So that's a compound, and we'll talk about all these in more detail later. And mixtures, where you can have compounds mixed with other compounds, or so you can see it as the compound here and another compound here, and they're all just mixed together. You've got two compounds here mixed together, and that's what a mixture is, okay? So which of the following is a compound? You've got air, seawater, distilled water, or rock. So air, as we know, air can vary. So for instance, if I stood right next to a coal-fired power plant, there'd be lots of CO2 in the air. But the air would still be called air. So that's definitely a mixture. Seawater can vary in its salt concentration. So for instance, in the Dead Sea, there's so much salt that you can actually, it almost looks like you could stand on it. It's much more dense than water, than normal salt water, but it's still called seawater. So B is a mixture. Rock could be anything. It could be a billion types of different rocks. So it's more likely to be just a mixture. So C, distilled water, is a compound. Water is a compound, so we know that. Which of the following is an element? So we know water vapor is definitely not an element. Ammonia is NH3, so that's definitely not an element. And we know carbon dioxide isn't an element. But oxygen gas, even though it exists as a molecule of two oxygen atoms combined together, it's still an element, okay?